Welcome back. Today we're going to get into the weeds on a single piece of gear. It's a box that solves one of the biggest headaches in broadcasting.
Yeah,
Getting uncompressed 4K video from point A to point B when they're like 10 kilometers apart.
exactly.
We are doing a deep dive on the DVIGear DVI-7348. It's a 12G-SDI fiber optic extender.
And our mission for you, the listener, is to really understand why this kind of gear is so critical right now. We're talking about taking these huge, vulnerable broadcast signals and turning them from copper into, robust light.
So at its core, it's a converter, right? SDI to fiber. But it's built for some really tough environments. And I think the place to start is just the sheer speed.
Absolutely. The headline feature is the 12G-SDI standard. Think of that as the pipeline you need for flawless, uncompressed 4K video at 60 frames a second. It's a huge amount of data.
A massive amount.
But the crucial thing for any engineer is that, yes, it handles that top-tier 12G, but it's also completely backward compatible. It'll work with any older SDI format you might run into on a job.
Okay, so the speed is impressive, but for me, this is the game changer, the range. It uses a single strand of single-mode fiber
Just one.
to get that signal up to 6.2 miles. That's 10 kilometers. But hang on, why fiber? I mean, why not just use a high-quality copper coax cable? And a single strand, doesn't that feel like a massive point of failure for a live show?
That is a very sharp question.
Yeah.
And the answer is all about signal integrity. Over that kind of distance, copy just gets noisy.
Right.
Fiber, on the other hand, is basically immune to all that. It has a low RF finding profile, which means all that radio interference, that electromagnetic noise that just destroys a copper signal. They can't touch the light in the fiber.
So it's actually more reliable.
But way more reliable.
And if you're running a cable 10 kilometers, it has to survive the journey. I mean,
Right.
the gear itself has to be tough.
And it is. The units are housed in these really rugged die-cast metal cases.
Yeah.
And the temperature range is, it's extreme. We're talking from -40 all the way up to +185 Fahrenheit.
That's insane. That's built for anything.
Pretty much. Functionally, you get a pair of them. A
Yeah.
transmitter, the TX, which takes your SDI, and it has a loop through so you can monitor locally.
Okay.
And then the receiver, the RX, it gives you two buffered SDI outputs. So you immediately have options for, say, redundancy or sending the signal to two different places.
All right, this is where it gets really interesting for me because it's not just a video pipe. Let's talk about control. It supports RS-485 and tally light control.
Yes. This is what makes it a proper piece of broadcast kit. It's not just a video link, it's a whole nerve center.
So you can actually control the camera from the studio.
Exactly. RS-485 is the protocol that lets the control room send commands back to the camera in the field. And it has its own dedicated 2.5 Gbps optical data rate just for that. You can change settings, talk to the operator, and of course, run the tally lights so they know when they're live.
And we have to mention the audio to get the full picture.
Oh, yeah.
That 12G SDI compliance means it carries up to 64 channels of embedded 48 kilohertz 24-bit audio.
So you can basically get rid of your separate audio snakes for a big concert or a sports event. It's all in that one fiber.
So to sum it up, this little box transforms this massive video signal into light and then shoots it miles down the road on a single noise-proof strand that also happens to carry, a huge amount of audio and all your camera control signals.
That's the whole package.
Yeah.
So a final thought for you to chew on. Considering that extreme temperature range and that long-distance single-fiber transmission, what sort of crucial real-world events is a tool like this making possible? Think about everything from live sports in massive stadiums to, say, nature documentaries shot on remote mountain ranges. Where is this technology fundamentally changing what we can capture?